and welcome to Component Rescue Board Repair. My name is Harrison, and I will be working on a board today. It's going to be an 820-2849 with no power, so let's go ahead and get started on it. So I'll switch over to the microscope and get this plugged in, and as you can see, there's no fan spin, which means that the computer is not turning on. So first thing we got to do is we got to figure out why it's not turning on. So let's see. So it looks like the CPU is turning on. So we can go ahead and verify that by switching over to the I'm going to switch over to the board view real quick. And we're going to search for CPU vCore, which on this, we need to let's see, I'm pretty sure on this board it's going to be vCore ASO CPU. So that's going to be our CPU vCore. So let's go ahead and check if that's going to be present. So let's see. Looks like we can find that right here. So let's go ahead and switch back over to the microscope, and then we'll get that checked out. So that's going to be this little spot right here. So let's stick the multimeter on there and verify that it is indeed turning on. So we're going to put one probe on ground and one probe right there. And we appear to get 10 millivolts, which means that the computer is not turning on. So now to figure out why the CPU is getting so hot. Now there's a couple of reasons that this could be happening. It could be that the CPU is shorted internally, or it could just be that part of the CPU is turning on, but it's not turning on fully. So first thing we're going to check is to make sure that the CPU isn't shorted, because if the CPU is shorted, then this board is pretty much trash. So let's go ahead and check that real quick. So we're going to check the resistance right here, and it should be a couple of ohms. Okay, and we're getting 43 ohms to ground, so that should be fine. So next thing we're going to do, since this is getting no power, is we're going to go through all of the power rails on the computer. So now for that, we're going to switch over to the schematic, and we're going to figure out where all the power rails are. Let's see, here they are right here. So, oh no, let's go back, there we go. Now we're going to zoom in some. So this first one, right, so let's start up here at the top. PP bus G3 high. So let's see where we can find that on the board. looks like we can find that at this little cap right over here. So we're going to test it on this little cap right here and see if PPBus G3 Hot is present. So we'll go ahead and get the computer plugged back in. Switch our multimeter back to voltage. And we're going to measure this point right here. And it looks like we're getting about 8.4 volts, which means that there is some kind of issue with PPBus G3 Hot. More than likely, it's going to be an issue with the SMC, or some issue with the charging circuit. So, what we're going to do next is we're going to find the charging circuit, which on this computer is going to be the ISL 659. So that's going to be right over here, right there. Let's go ahead and add me back to the film. So that's going to be our little charging circuit right there. So from experience, just knowing that we're getting 8.4 volts on PPBus G3 Hot means that there more than likely is going to be an issue with either this component or with the SMC. So what I'm really hoping, oh, microscope cam, come on, focus, come on. Okay, fine, don't focus. So more than likely, there's going to be some kind of issue with this. Because on this specific board, PPBus G3 Hot is supposed to be 8.6 volts. So anything lower than that, or anything above that, more than likely is going to be some kind of issue with this little chip right here, since this chip is what creates it. So we're going to take a little look in the microscope and see if we can see anything going on around this chip that might indicate that there's a problem with it. So, looks like there's a little bit of hair around there. Nothing too bad. Most of those solder joints look pretty good. Everything here, besides these stray little hairs, looks pretty good. Okay. So what we're going to continue doing at this point, since all of that looks fine, is we're going to keep going with the computer and see what other power rails are present or missing, and go from there to figure out what's going on with this computer. Since technically the computer can still boot up with the amount that was currently on there right there, we're just going to keep going down the line and see what else is going on with this. So let's switch back over to the schematic. And next is going to be PPBus, CPU, IMVP, INS, which is basically the same thing as PPBus G3 Hot. Then we have PPDCN G3 Hot, which we know for sure that we have because we have voltages everywhere else in the machine, and that's where the voltage comes in from the charger. And we also know we have PP3V42 G3 Hot because we have a light on our charger whenever we plug the computer in. And if there was no light on the charger, for there to be a light on the charger, this voltage has to be present. So the next thing we're going to check is so now that we know that all our G3 Hot rails are there, which are the ones that are going to be always on even when the computer is turned off, Next, we need to check our S5 rails. So, first one we're going to check is going to be PP5V-S5. So now we're going to switch over to the board view and find PP5V-S5. So, where's a good spot to find this? Looks like this little capacitor right here. It's going to be a nice little spot for that. So we can find that on, flip the board over real quick, and we're going to put this back on the microscope. So that's going to be right around this area right here. Let's get the plugged back in. And that's going to be this little spot right here. So what are we getting right there? We are getting 0 volts, which means that we are missing that S5 rail. So why are we missing that S5 rail? So now what we're going to do is we're going to go back to the schematic, and we're going to search for PP5V-S5, and we're going to figure out where this was created. So that's not going to be it. That's not it. That's not it. Oh wait, let me put you guys back onto the schematic. There you go. That's not going to be it. This it? No, that's power in. Where is this created? Okay, let's try this again. I must have missed it the first time. No matches were found. What? Where is this created? Let's see, what is this right here? Okay, this looks like the chip that's going to be making PP5VS5. Maybe. Is this it? Yes, this is it. Okay. So for us to be able to get PP5VS5, we're going to need the enable signal on this chip, and we're also going to need power going into it. So I already know that there is going to be power going into it, since this is powered off PP bus G3 hot, and that signal and that voltage is present, even though it is a little bit low. So what we're going to do is we're going to check the enable signal to see if that is there. So we're going to switch over to the board view and PP5VS5. Wait, what was that signal called? P5VS5EN. P5VS5 enable. There we go. So now we're going to be able to find that. I'm going to zoom out. Looks like that's going to be on the other side of the board. we'll get this flipped over, and then we'll switch back over to the microscope so we can see this right here. Okay, so looks like this little area over here is going to be right here. So I think we're going to test this just to make it easy. Is we're going to test it. Right here. On this little, we'll test it on this little resistor right here. And we are indeed getting an enable signal, which means one of two things. It means that either that chip right there has gone bad, or there is a short to ground somewhere else along the line, or possibly we may not be getting power in on the chip. So let's go ahead and figure out where the power is coming in on the chip. It's going to be on pin 23, and we can easily measure that on this little capacitor right by the chip. So right there, we are getting 8.4 volts, which is expected. Let's go ahead and check PP5VS5 right here, just to be sure. So we can check that on this capacitor right here. Looks like here we are indeed getting 5 volts. Yet elsewhere we weren't getting 5 volts. Could it have just been a fluke? Maybe. I think that might be the case. So next what we're going to do, we're going to switch back over to the board view, and I'm just going to go ahead and check to see if we're going to go ahead and just check for let's just check a few. We're going to check a few voltages like this right here. So I'm going to go ahead and check that on here just so I can be quick about it. I'm not going to switch back over to the microscope just because I want to probe this real quick just to see if it's there. Okay, and it looks like that is indeed not there, just as I expected. So next thing I want to check for is PP5VS3. So let's see if this computer is able to make it to an S3 state. So we can, of course, check that in this little area right over here. Maybe. No. Where's a good place to check that? Aha, right over here by the RAM, I believe that is. So where is this going to be? Yeah, by the RAM. That's going to be... That's going to be this little area right here on the microscope. So what we can do here is we're going to check for PP3V3 S3, which I believe was right here, or PP5VS3, and that indeed is there. So next what we're going to do, since we know that the computer is making it to an S3 state, is we're going to check to see if it's making it to an SO state. So let's see if we have PP5VSO, which I'm fairly sure we don't, since we don't have any fan spin on the computer. But we'll go ahead and check it anyways, just in case. So we can find that on the top of this capacitor right up here, which is going to be right here on the board. That's going to be right here. What do we have there? Oh, we do indeed have 5 volts. Interesting. So we do have 5 volts there, which is interesting because that's what powers the fans. However, the fans, as you can see, are not spinning unless I make them spin. See, if I make them spin, they will spin. But otherwise, they're not spinning, even though they're powered directly off of it. See this right here is 5 volt power, that's ground, and then these are the signals that tell the fan how to spin. So my guess would be that there's an issue, possibly, with one of those. So let's switch back over to the board view to see where those connect. So it looks like one of them connects to this little chip over here, which appears to control the fans. So, could there possibly be a problem with one of these? Yes, possibly. So let's see. So what is this controlled by? It's controlled by PP3V3SO. So, do we have that power rail? We'll go ahead and put it back on the microscope and add me to the picture too, just because. So, I can measure that right over here, and of course, there's going to be a little piece of tape over where I need to measure. That's okay, I can measure at this other little spot right here, and still get a good measurement. So we're going to measure right here, and stick the other probe on ground. Looks like we are getting PP3V3SO. So this little chip right here that's controlling it should be turning on. Which means, no. So if you look on the board view, what this chip talks to is it talks to the fans through these signals, through that one and this one, and then it also talks to the SMC. So let's figure out if there's any communication going on at all, or if that's shorted to ground. And we can figure that out by testing the voltage on the other side of this little resistor. And it looks like we have 0 volts there, meaning that that's going to be shorted to ground. Now, let's go ahead and disconnect power from the computer so we can check it out real quick. So what we're going to do next is we're going to test to see if that rail is shorted to ground. So we'll go ahead, put it on diode mode, so that way you can hear it beep like that if it is indeed shorted to ground. So I'll stick one probe on there, and the other one on ground. And it looks like it is not shorted. Let's go ahead and see what the resistance is right there. So the resistance is going to be 95.4 kiloohms. So let's go ahead and see what the pull-up resistor looks like, since possibly that might have gone bad. So looks like that's going to be 91.5 kiloohms. So let's go ahead and check that in the schematic. So the board view says that's R5651. So then we're going to go over to the schematic and we're going to search for R5651. And we're going to figure out where that goes. So it looks like that's right there, and it's showing as a 100 kiloohm resistor, which is close enough to what we measured. Which more than likely is going to mean that there is some kind of SMC issue. Now, it could be that we're just missing an SO power valve, so the SMC is not putting these out, which is very likely, very, very likely. Or it could also be that we have a dead CPU or a dead SMC. Hopefully it's not one of those, but we'll see. So, next what we're going to do is we're going to go back up here to our list of all of the power rails or aliases or whatever Apple calls them in this specific one. Here we go right here. So there's PP3V3SO and PP5VSO, which of course, wait, oops, let me switch you guys over to the schematic. Here we go. So there's PP3V3SO and PP5VSO, which we've already tested, and are both indeed there. So now we need to check PP1V8SO and see if that is on the board. PP1V8SO. Okay, looks like there's quite a few spots we can check this. Where is PP1V8SO? That's in a good spot to test it. PCH. We can just test it on this little resistor right here. That should be perfectly fine. So that little resistor is going to be and looks like that resistor is not actually on the board. So what we're going to do, we're going to get the computer plugged back in, since you never want to test the resistance of something while you put in power on the device. That's why sometimes I'm having to have it unplugged and then plug it back in. So we get that plugged back in. Switch the multimeter back to voltage, and we'll test the voltage right there. See what we're getting. So we're getting 1.8 volts, which means this is working exactly as intended. Right there, we're getting, what is this supposed to be? 3.3 volts, yes, so that is indeed correct. Okay. So now, we're going to go back to the schematic. After I figure out why this keeps randomly changing pages, God, I need to get a better one of these. I like the one on my Mac so much better. But the problem is with my Mac is that there's no drivers for all of my cameras. So I can't actually do any of this on there. No. No. No, we went too far. Too far. Almost. 8, 7. Here we go. This is what we need. So, let's zoom out a little bit. So we have PP1V8 SO. DDR rails, and those aren't too important right now because those aren't related to what we're looking for. So we're going to need PP1V5SO. So we'll go ahead and go back to the board view. PP1V5SO. And you may be wondering, is every computer this complicated to diagnose? Well, some of them are. I'm not sure why exactly I did this, but for some reason I decided to do my first stream as one that's probably going to be incredibly difficult to diagnose and may not even be fixable. But that's okay, because we're just going to keep on chugging along anyways. So let's get the microscope positioned, and then we'll switch over to that. Okay, so this is going to be the next spot. We can find PP1V5SO right here on this little capacitor. And we do have that right there. So what's going to be the next power rail we need? Oh no, you piece of crap. No. Why do you do this? Piece. I'll switch back to the schematics in a moment. And we're going to go ahead and get me another mouse connected, which hopefully will work a little bit better. There we go, maybe. Aha, beautiful. Maybe this one will actually work. Here's another thing we're going to do real quick. We're going to go to, how do you, no, we're going to change this so that this will stop. I don't know how to do any of this. Just wish this would work. Oh well, we can figure this out later. Maybe it's one of these. No. Maybe something on here. No. We'll just have to figure that out later. Okay, next is PP 1v2SO. So we'll go back to here, PP1v2SO, and where can we find that? We can find that right over here. So that's going to be on this little diode. So we can find that on this diode. So let's go ahead and test that out. And we're getting 1.2 volts. So next we need to check let's see. We got PPV core SO. Actually, I know we don't have CPU vCore, but do we have GPU vCore? Let's check that real quick. So we can find that. PPV core SO. No wait, PPV core SOGFX. Maybe no. That's not it. It's. Oh, maybe it is it. So that's going to be, get the microscope position on these little caps over here. So that's going to be on these caps. So we're going to check right there and right there. And we have no GPU vCore. Actually, we're going to go ahead and check PPU vCore GPU also, which we can find right here on these caps. Yeah. So let's go ahead and test for that. See if we have GPU vCore at all. 0.90. So we are getting some power on the graphics chip, but we're not getting what we need to turn on. So this one's looking like it's not going to be an easy one at all. In fact, this one I'm starting to think is probably going to be a dead SMC. But we can still check this out a little bit. Which I'm not sure if you guys know how difficult it is to replace an SMC, but it's definitely not fun. Let me see if I got one laying around that I can just grab real quick. I got one laying around, maybe. Maybe. Oh. Yeah, here we go. Right. Thank you. So yeah. So here, I'll go ahead and stick it under the microscope so you can see it. This little chip that I'm probably going to have to end up replacing on this board, since it more than likely has a dead SMC. So this is the little chip right here. This is just a dead one that I pulled off of the board. Actually, we'll go ahead and do it on this. Propping that. There we go, right there. Nice and beautiful. Ah, come on, adjust. There we go. What a beauty. See, look at that. And the best part is, on the other side, look at that. Look at all those balls. You get to put solder on all of these little tiny balls right there. Let's see if I can get that in focus a little better. Maybe. There we go. That's pretty good right there. This solder gets to go on all these tiny little balls. And then you get to put it back on the chip. And you get to put them on the little balls by using this wonderful little stencil thing. And you get to put it on there, and yeah, the whole process takes like an hour. It really isn't fun. But it's kind of looking like that's more than likely going to be the issue with this board. So I was hoping I could have a fun one to show everyone, but looks like it's going to be probably a dead SMC. We still have a few more voltages we can check out, but since everything seems to be turning on, besides the fans, the CPU and GPU, I mean, there's a couple of things it could be. We'll see. Okay, let's actually go ahead and get the board back over here. Here's our board. What a beautiful board. Look at that board. How nice is that? Okay. So, we're going to keep going through these voltages right here. So what else do we have? Actually, you know what, let's figure out why CPU vCore isn't there. So we're going to search the schematic, go over to the schematic, ppvcore, no, let's get rid of the file, ppvcore SO CPU. And we're going to figure out everywhere that this shows up. No, that's where it goes to the CPU. Decoupling caps. But what we want is where it's made. So it's vsense. Where, aha! Here we go. So this is going to be where it's made. So right here, what this does is this turns PPBus CPU, IMVP, ISNS into CPU vCore, which this right here is pretty much just PPBus G3 hot. So what we're going to do first is we need to make sure that this is indeed being told to turn on. So let's go ahead and figure out and see if this chip is turning on and outputting the voltage correctly. So right over here is where that's going to be made. So first off, looks like here's the two different phases. There's one down here, one up here, so that it can output different amounts of power. Here's where they're created. Here's all of this stuff. But let's see if we can find the enable for this. I cannot remember what it's called off the top of my head. So I may have to check another schematic to figure out what the enable for this is. So let's see what all this is. This is all for creating the voltage. This is for vSense. This is for communication with, I'm pretty sure, the PCH. This is for more sensing circuitry. So I'm pretty sure it's going to be this CPU IMVP VR on. So U7400, it's going to be pin number 35. So let's go ahead and switch over to the board view. And we're going to find U7400. And we're going to look at pin 35. Which, where else? Is there a better spot we can find this? Looks like there's maybe a test point over here. Which, if we can't find that test point, we can always test it directly on that pin. I just usually prefer not to test it directly on the pin, so I don't accidentally short something up that I don't mean to. Let's see where this is going to be. This is going to be right over here. So we'll go ahead and switch this back to the microscope. So it looks like that little area I'm looking at, this is out of focus, there we go, is going to be this little area right over here. So a lot of times these little probe points aren't all in the correct spot on the board view. Sometimes they're ever so slightly off. So this is told to turn on by the SMC. So we're going to go ahead and see if we can get any power from it. First we're going to plug it in. And we're going to check this point right over here. I believe it's this one right here. And looks like we're getting 0.2 volts, which I don't believe is going to be the correct voltage for this. What's at this probe point right here? 0 volts. What are these supposed to be right over here? PP1V8SO feedback. Okay, well, that makes sense that would be 0, since that's powering the RAM, and there is no RAM inside this computer right now. So it is looking more and more like this is going to be some kind of SMC issue. Which, let's go ahead and just look at the SMC and see if there's maybe any liquid damage or just any damage at all in the vicinity of it. So we're going to go and zoom in nice and big. Make sure you guys can see that. Okay, you can, kind of. There you go. So we're looking for maybe damaged probe points around here. Let's see. Maybe there are any. See, some people may think that this probe point right here looks bad, but really this is fine. That's just a little bit of crap on it. And people may also think this one right here looks bad, but this one's also perfectly fine. What about this one? How's this one doing? And that one appears to be fine. This one is indeed a very tricky one. So here's what I'm going to do. I'm going to check and see on the actual chip right here. Go ahead and zoom back out so you can see. I'm on the actual chip right here. Rotate it a little bit. Get that back to normal. There's the actual chip right there. Ooh, that is really out of focus for you. There we go. Come on, adjust. There we go. Okay, so that's going to be the little chip right there that we're going to test on. So let's go ahead and go back and see which pin that's going to be. So that's pin 35, which is 1, 2, 3, 4, 5. So it's going to be the fifth one from the left on this little chip right here. So 1, 2, 4, 5. So it's going to be that little pin right there. So let's go ahead and plug this back in, since I unplugged it whenever I was probing around a moment ago. So we got it plugged back in. And we'll go ahead and check out 1, 2, 3, 4, 5. And we are getting no enable signal, which once again leads me to believe that we're having some kind of SMC issue. Since this is told to turn on by the SMC, it's getting late. So let's see, what pins are around this? Maybe there's something similar between all of them. Nope, not that I can see. Let's check this one. Let's switch this back to the board view. There we go, there's the board view. So here's the chip right here for the graphics. Let's see why this one is not turning on. Is this one also told to turn on by the SMC? Let's see. So this one, what enable signals do we have? We have, I'm pretty sure, this is going to be our enable signal, which comes from, looks like it's coming from the Yeah, I actually can't remember what that chip is. And, of course, something near the SMC. Let's go into there. And all sys power good, which is going to be missing. Gmux S. So it looks like this is being told to turn on just by this little thing right here. So we're going to go ahead and see if that is here or if it's missing. So let's switch back to the microscope and we'll get this flipped over. Because obviously something on here is turning on because this board is seriously heating up, especially on the heatsink. But it's very strange because it seems to be heating up on the right side a lot more than the left. Actually, ooh, did I just see a little bit of a fan spin? Let's see what happens when we use a different DC mag. Okay, we got that plugged in. And let's see what happens now when we plug it in. Looks like now we got a small amount of fan movement on this fan right here. Or maybe I'm just imagining things. Let's see. Did we get any movement? Maybe I'm just imagining things. Anything? I don't see anything. Let's see. I'm going to go ahead and double check that home. Well, this is interesting. With a different DC now. We get no light on the charger. So see now, look at this. So I swapped it out for another DC mag. And on this one, there's no light on the charger. That's interesting. Let's see if maybe I have another one of these lying around that I can test. Let's see. Oh, I have one somewhere over here. Maybe I have one up here. So give me just a moment. I'm going to see if I have one more. I'm just going to switch you over to something else while I try and find me another DCN board to see if maybe that was the problem the entire time.